Hey everybody, it's the 1st of April, 2025. This is Aiken PBL live coding, Gimbalabs and friends. We started this course a few months ago, have been rolling out lectures as we work through the course, and we wrapped up the first series of lectures a few weeks ago. And over the last few weeks, we've been doing two things. One, we've been having Q&A sessions from students in the course or other people who are building things. And number two, we've had some kind of advanced lectures. Hinson prepared some notes about mistakes that people make when they're learning how to use validators and obstacles to avoid. And I think there's a companion to that around application design coming up next week. So we're looking forward to that. On the 8th of April, we'll have Hinson back in the lecturer seat talking us through building an app. But today we got Lawrence, one of our PPBL maintainers here at Gimbalabs, who's been doing a lot to think about how to make Cardano development more accessible. Author of a textbook, you can find it on Amazon, professor who's bringing these lessons into the university atmosphere. And I guess you've been taking on the testing bit and thinking about how to run more of a local environment so people can run sets of transactions. Is that what we're covering today?
That's correct. Yes, absolutely. So thanks.
Beautiful.
Thanks.
Welcome.
Thanks.
Yeah, thanks for joining us, and I'll hand it off to you, Lawrence.
Sure. That's great. Yeah, glad to be here, guys. Good to see you all. And Henson, a special call out to yourself. I think you're doing some great work. I've been using some of your tools, so keep it up. It's awesome. So what we're going to show then today is as part of the PBL maintainers, we kind of did an update of all, we looked at all of the examples. And so there were some examples that were kind of old and they needed to be upgraded. So both from they had an older Aiken version as well as they weren't focused on Plutus V3. So let me share my screen and I'll just kind of go through what we've done. So what we'll do is I'll go through what we've done in this case on the examples, and then I'll show you some of the testing features that I've put into it because as James had mentioned to it's when you're developing, you really have to have a testing mindset because that just tells you right away whether things are working as you expect. So I just kind of, do as I say, right? We talk about testing, well, let's just do it. So that's what I did. So I just want to show that and you can kind of use that as a reference or a starting point. So let me share my screen here. So share. So some captures, a little different type. Yep, okay. So I think share. Hopefully this all works. All right. So I assume you guys can see my desktop. Is
Yep,
that
looks good.
correct? All right. Okay. So inside the PBL Aiken examples, obviously, throughout the course, there's a number of different things here, but the big upgrade was the PBL faucet. So this is where I'll just focus on, and this is where most of the testing test cases occur. But I did put all the unit tests into these other ones as well. Just again, just they should always be there. It gave me the confidence to know, yeah, this works, so you should always have it. So let's just go into the directory for a sec. And so there's basically, I've added a test directory. We'll get to that in a second. And then there's the validators. And I'm going to switch over to the IDE because that's easier to see. Okay, so let's look at here. So top level of the PBL faucet. So no surprise here, the Aiken Tomo file, just we did an upgrade again to this. We're using version 1.19, but the older version was, I don't know, 0 point something. And then obviously it's Plutus V3. So that's a small change that we made. And then got a more recent version of the standard library, and then brought in this the vodka library here. So that has the unit testing framework that I used. So that needs to be used as a dependency. And then probably had upgraded the version, I believe as well. Okay, so we needed to have that as kind of the base. And then let me just go to the validator itself. Let's scroll all the way up here. So, so there was again a few changes from the prior version. Again, certain things just kind of moved within the libraries, but basically, it was more or less the same. Just some small maybe syntax and moving of libraries. So those should be very familiar. Obviously added these pieces here. So this is the mocktail. And so if you go over to, let me go there for a sec. I'm just going to go grab here. I kept the tab over. just going to show you where the library is. And again, you probably I already have it here. So this is the vodka library, and again, it has kind of two parts to it. So it has something called cocktail, which is useful for writing on-chain in Aiken. But what we're looking at for more is on the mocktail kind of piece, which is really how we create unit tests. So we're going to go into some of those examples. And again, that's what I'm talking about, where just by default, when we build the validator, I always just include the unit tests as well, so you can basically quickly check it, and we'll see how that works. Okay, so that's basically so we're going to import those mocktail modules here, and we'll see where we use these, but these help us construct transactions, kind of fake transactions. So with this the PBL faucet, you've throughout the course, actually, this same smart contract logic is actually implemented in Plutus or Plutus, the Haskell version, as well as other versions. But anyway, so we'll go through here. But you're probably familiar with this concept, these concepts, so I'm not going to go through them too detailed. But basically, we have a datum, right? So we specify, and obviously the purpose of this script is basically to, it's a faucet to get tokens. So there'll be a datum associated with the UTXO that's locked into the script address. It specifies the amount of tokens that can kind of be withdrawn. It also specifies the faucet token name. Redeemer has to specify basically who's making the request, so we can do some verification to make sure the tokens go to the user, as well as the access token names. The only way you can withdraw funds from this script is if you actually have an access token. And then again, that's part of the course where you mint an access token. And if you have an access token, then you're kind of allowed to withdraw and get these faucet tokens. So the actual validator itself, again, some changes from as part of the upgrade and the syntax of Aiken is that now you have obviously specify your validator here, and you obviously specify the validator name. You pass in parameters here. So this basically is, and you're probably already familiar with this, where these parameters are passed to the script and they kind of bind to it. They're like hard-coded constants, and obviously they once those are created, that creates a unique signature for the script, and so those things are kind of hard-coded into the actual script. And then we specify the spend. So there's obviously different types of way you can invoke a validator, whether it's a spend or a mint, for example. And so then this is probably familiar to the previous versions, but you have the spend, specify the datum. With the latest version of Plutus v3, the datum is now optional. And then there's the redeemer, and then there's a output reference in a transaction. And what Aiken does is they've kind of pulled out and they provide these kind of variables to the spend transaction. If you actually, in the Haskell Plutus TX version, you actually have a little bit more control. And at the end of the day, that part of Plutus v3 is really, you just have access to the input, basically the script context, which is the inputs and outputs, and you can kind of figure everything out. But Aiken makes it a little more simpler because they can actually explicitly pass this stuff to you, just because these are the things that you usually need, right? So you usually need to see the redeemer, and an output OREF is basically what's basically the UTXO that is mapped to this that's being used as an input for the script address, and then the transaction. So again, I won't go too detailed, but I'll just quickly review it because then this is going to make a little more sense when we talk about the actual, like, what are we trying to test. So so basically, we pull out, we deconstruct the datum, right? So it's an optional datum. So we say sum, so we get the withdrawal amount and the faucet token, right? Because that's exactly what we had in our datum up here. There'll be a withdrawal amount and the token. Again, same thing, we'll deconstruct the redeemer. So we get the sender PKH and the access token. And then we'll also deconstruct and pull out the inputs and outputs. And so that we'll go through, these are kind of like helper functions and utilities to get kind of all the information we need to do our checking. So we're going to basically pull out and get all the inputs, right? So we basically just utilize that OREF that was passed as a parameter to make sure we get the right input that matches the input that's locked to the kind of the script address that we're spending. So we'll do a little filter there. So now we have the faucet input. Do a similar thing with the faucet output. So as we remember, you have basically our transactions going to have a bunch of inputs and they're going to have a bunch of outputs. So we just need to kind of match them up. So we want to make sure we get the right inputs and outputs for the faucet. So that's what we do here. We just apply a filter to all our outputs and just make sure that the input that we got here and its address matches the output address, right? So we kind of make sure, because obviously the script address isn't going to change. So we just want to make sure that we got the right input and output. So once we have that, then obviously we go through, we find we're going to basically find the tokens. So this is going to be the access token. So we're going to be using this later, but let's find the token. So that's great. So we're going to find the input that has the actual input, the access token. And again, the only way you can spend this validator is if you have an access token. And so we're going to find here's the inputs, and then we're going to find the output as well, because we want to make sure that that access token doesn't disappear. So we do a search on all the outputs and make sure that's there. So that's great. And then we start building some of our conditions, right? So we must send the token back to the sender, right? So we want to make sure these are equal. The access token doesn't disappear. And then the faucet output to sender. So we're now going to figure out how much goes to the actual sender. So we do the quantity of, and we match it to the withdrawal amount. And again, our withdrawal amount is what we pulled out from the datum. If we go back up here, right, that was the withdrawal amount. And so we basically are finding, okay, so how much output tokens go to the sender, and then how much did they have in the input and output. And then we obviously just need to also check the key, because we want to make sure these tokens go back to basically the person who has the access token and spending. So we make sure that that's correct. So again, we pass that as part of the redeemer. We actually passed in our sender PKH. If we look up here, part of our redeemer, right? So redeemer sender PKH, and we figure out what the remaining tokens are going to be. We just got to make sure that it all adds up, right? Because we're going to have, the script itself is going to have a bunch of faucet tokens locked into it, and we're trying to, as a faucet, trying to spend and grab some, right? So we're trying to grab the withdrawal amount. So therefore, mathematically, we should have the number, the input should basically be the output plus the withdrawal. And then we're getting here. So now here, a couple more conditions is basically we want to make sure the datum remains the same. So this is an important vulnerability you need to make sure you watch for is, in this case, the assumption is that the datum has kind of that information, and it shouldn't change. So we got to make sure it doesn't change, right? Because our datum, if we all recall up here, is basically it's telling you what the withdrawal amount should be, and then really what the faucet token name should be. So those are kind of hard coded into the datum, and we just need to make sure that that can, when we spend the UTXO that's locked to the script address, and we create a new UTXO that's going to get locked, we actually maintain the datum integrity, so it stays the same. And then we put in a little question mark. Again, this is just putting in a debugging flag. It's optional, it's tracing. You would actually remove this when you go to production, but I'm just keeping it in there just so you can see some of the logic that's getting executed in our test cases. So, okay, so first of all, we make sure datum's there is the same. We do obviously must send token to sender, right? So that was up further. We evaluated that Boolean condition. Must the faucet output to sender, right? Make sure that the faucet amount is getting to the tokens. And then equally important that the remaining tokens goes back to the script. And then make sure that the output, including the faucet and the access token, goes back to the person with the access token who initiated the transaction. Okay, so those are all the things that are going on. So that's fine. So some of that shouldn't be new, and I think you probably have all actually used this so far. Okay, so let's figure out, well, okay, so that's great. We made all these assumptions, and how do we start testing this? So that's where we're first going to use these unit tests. And with testing, there is two approaches, or there's many layers actually, but there's two main layers. And the first one is really these unit tests. And that's where the vodka library is great. because inside the Aiken file itself, we're actually defining the unit test. So we'll first do these unit tests and show what they look like. And then I'll show you what kind of the integrated tests look like. And that's a different thing. And that's where we'll go into Yaci dev kit and some other tools. But let's look here at the unit tests. So what we need to do is we actually have to create these mock transactions, right? So our first thing, so is basically we're just going to create a function here, and we're going to start populating all the things that our script actually needed, right? Like we need to, we're going to pass a datum, we're going to pass a redeemer, we're going to pass like the wallet address, the script address, the policy IDs of the access token and the faucet token. So we're going to pass all these things here. We're just going to use this. You can basically put a flag, whether it's true or false, as owner signed. But in our case, mostly we'll just be passing it true. But again, you may have certain conditions around whether the transaction is signed correctly or not. So, okay, so we've got this. So so these things are going to get passed, and I'll show you the calling function of this in a sec. But if we pass that information here, this is where we actually create the transaction. So we take these parameters we're passing to this function, and then we start actually creating these kind of objects, right? Like, so we're going to create an access token value. So we're going to pass the name and put in some default Lovelace, create the faucet tokens. And now we start creating the transaction right here. So we put in, okay, so we're going to have an input. So, okay, so this is going to be an input. And we'll basically put in a specific, basically the hash and the index, right? So we're creating a UTXO here, right? So this is an index. So it's going to be faked, but that's okay. There's things that we can fake that still legitimately test the script. And so we really don't care about the actual hash number. We just need a number because we're not validating the actual hash, like whether it has X, Y, Z, A, B. But what we are validating is that we have one UTXO as an input here, and it has an access token and the wallet address. So this would be the input that would be spent from the actual wallet of the user. We're going to want another input into this transaction. And again, so we'll have a different UTXO, but we'll just put like 1 and 0. That's fine. And then obviously it's going to put in we want the faucet token value input and the script address. So we're going to pass in that. So this is going to be the input that's locked to the script address. And we're also going to attach a datum to it, right? Because that's a requirement. We need to have a datum. Our script will fail if there's no datum associated with this UTXO locked to the script address. Okay, so that's basically our two inputs. And then, well, we need our outputs. So let's create those. So the output, so we'll put in the wallet address because it's going to go back to the wallet address. And then in this case, we're just going to merge the access token and the faucet token value output. So this is what's going to be returned. And again, so I'm just making these up, these numbers in a sense. First, I'm going to do a happy path, right? So you can see my faucet token value output. If I look at the input, I'm going to say, okay, there's going to be 1,000 faucet tokens. And then in order for this to succeed, I'm going to say, well, okay, so I'll say that this user is going to redeem 100 tokens. So I'll just put the 100 there because that's what I've specified. You'll see it in the datum below. I said, okay, it was going to be $100 token withdrawal limit. And then the remaining is going to be 900, right? So that's what we'll do, right? So, okay, so that's the faucet. So this is going to have the 100 tokens go to my wallet address. And then the second output will be the remaining, which will be the 900. It's going to go to the script address. And then we'll basically attach a datum again. And then we'll make sure that it is signed by the wallet owner. Okay? So there. So we've kind of satisfied, in our view, we've satisfied the condition. Right now, there's no reason why this script shouldn't succeed. And so then this is the actual test function. So you need to put test, and then we actually have, again, this is going to be happy path. So we just, again, I'm going to create some mock data here. So we're just going to say what the wallet address is. We don't really care what it is, but we need to be consistent. So it's just going to be a bunch of zeros. Script address is going to be, again, this is what you're going to have here for your script address. So it'll be a 1. And the none is, I think, the related to staking. So don't worry about that. So then we create those addresses, and then we create our policies. And then we create our datums, right? So we needed to pass a datum. So that's where that 100 basically withdrawal limit is specified. And then I'm just going to put in a token name. That's fine. Can be anything right now. We just need to be consistent. But anyway, that's going to be the token name. Redeemer, same thing. So we're going to basically specify that this mock public key hash is 0. And that's just kind of a default. So because this is kind of, this is, we're just using kind of the first, the 0 for this public key hash. This will map back to this. So anyway, so those are just consistent. And we'll see when we have an invalid key how we do that. But anyway, right now, so that's just consistent. They're both 0 here. And then the access token name. So then the output reference. So again, this library we have is great because it has all it simplifies the construction of these kind of objects that we need to build up a transaction. So to create a mock UTXO reference, again, we're just going to call 10, and that's fine, right? And we know this is why it's kind of important. So when you're doing these testings, you can't just kind of copy and paste. You have to really think about where things are going, right? So anyway, so this is you do have to think about what you've set up over here too, right? Because this is where we defined, right? So this is going to be the first. This is going to be our first input, and this is our second, and then ultimately this is, we have to think about where things are going to land. Okay, so let's go down here. So then when we create the actual transaction, we basically call mock_tx, which is up here, right? Mocktail tx, so sorry, right there, mock_tx. So we're going to call this function now, down here. And we're going to pass in those parameters like we had reviewed, right? So this is all the data we need for that mock transaction. And then finally, we get to the point where we're actually going to then kind of spend or actually execute the smart contract, right? So we're going to, that's the PBL faucet spend, right? So that's just, we just go right up here. And that's why it's nice. It's right inside the file, right? So we're just going all the way back up here. All right. So we're just spending the actual, inside the Aiken code, we're actually going to call this function, which is the spend transaction. And so we're going to spend it. So we're going to, again, pass what we need, the access token, the faucet token. We're going to pass in, again, an optional datum. So we'll put a sum around it, the redeemer. We'll have an output reference and the TX. So, okay, so that's kind of happy path. So everything should work. So let me do that, and then let's see what happens here. So let me go over here. Okay, so all right. So I'm in here. And just to go over this inside, I'm just going to go into here for a sec. Inside the test directory, I've created a bit of a README. So there's some, we'll get to it, but there's the whole creating using Docker desktop. But I'm just going to jump quickly over here for a sec to the Aiken piece here. So obviously you've got Aiken up and running. You should use obviously the instruction about Aiken up to basically install, right? So everyone probably should be at this stage here, following the installation instructions for Aiken using Aiken up, installing it. That's fine. And so I will just see what Aiken version I have. Aiken version, hopefully, yeah, so that should be fine. I actually had to compile my own, so a little bug anyway, so if someone is new watching this video and they try to basically go through Aiken up, and they get this friendly message, a legal instruction, you may need to compile it by source. So for my case, I'm running Ubuntu 26, I think. So the later versions of Ubuntu are one of my, okay, 24.04. In my case, I needed to actually build Aiken from source because the Aiken compiled version didn't work. But anyway, regardless. So once you get this installed, ultimately do it here. So you have your Aiken version. Right now, we're just using version 1.19. It's not the absolute latest, but it is the kind of the more recent version that we're going to be using. And so once you basically downloaded the examples and you're into the PBL, so like I am, so right here, right? You can then just do Aiken check, right? So we run Aiken check. It's going to compile it. And what it's going to do is then, you can check obviously the syntax that the file is correct and doesn't have any errors and warnings. And then it does this output here. So basically, this is where it's actually executing these test cases. So you just it becomes kind of your default behavior, it's just there. You can, again, you can avoid having, you can reduce some of the verbosity of these details here. You can avoid the tracing flags. I have them here just so you explicitly see them and so you know what's going on. So the test case that we reviewed was this guy. That was success. So that's exactly what we want to do. So we kind of set up, we built the construction of the transaction, thinking this should work, and it did work. So that's good, but clearly that is not where it ends, right? You basically, what actually is more important is to understand the boundary conditions or the error scenarios. So there's a whole bunch more things that are going to test, and we want to make sure these things are actually fail. And so obviously we basically, expect it to fail. So one of the first things we would do is then, let's make sure, let's try the wrong amount, right? So if we recall, we have, if I go down over here, we're going to specify the input. So in this case, again, we reset it, this is a whole new kind of transaction, so it doesn't use the other one, but obviously you could kind of chain it if you want, but in this case, these are all separate, unique kind of transactions. So we have 1,000 tokens that we're going to start from, right? But we're going to basically, are only going to have a withdrawal amount of 100, but we're actually going to fake it and we're going to say, well, no, we're going to try to withdraw 500 and then leave 500, right? So that's wrong. So that's a good example where, okay, we're going to test this logic. The transaction should be able to catch this. The smart contract should be able to catch this, that this is incorrect, right? And so then we build everything like we did kind of before. Right? So everything looks fine. Key here is the datum. That's what's specifying the withdrawal limit. So pretty much everything is identical to before, except for this piece here. We've kind of manually set the wrong amounts. We're trying to do the wrong withdrawals. And so when that runs, right, and then we specify a fail, so we're kind of expecting it to fail. If you look over here at the top one, right? So we just assumed it to be, if it's successful, if it's true, then it's a success. In this case, I've said, okay, let's make it actually, I want it to fail. And if it fails, then that actually means it's a successful test case. And that's exactly what we saw here, right? So then basically, when I tried to do wrong amount, it actually passed and it worked. Okay, so that's cool. So let's look at the next one that failed, that we wanted it to fail. So the missing access token. Okay, so how do we do that? Well, in that case, we basically, everything's similar, but we're gonna have the right amounts this time. And we just, it's in part of the transaction construction, we just don't have it, right? And there's lots of different, it could be the wrong token, for example. Again, we need that access token. There's only one of them and they need to be there. In this case, so we're just basically, all we're providing is an input of the UTXO that's locked to the script address, right? And then we try to spend and whatnot. And I make a few things to make it a little more pseudo-realistic in a case that, so the output, I'm not actually trying to put in an access token because I don't think it exists. Because you'll get failures at different rates, right? So when you're creating these test cases in the negative, just be aware that there'll be failures of like failing to balance a transaction. And so that's great, right? That's important, but you're not actually failing on the smart contract side. So sometimes you need to massage this a bit to basically make sure it passes the balancing of the transaction and gets actually into the smart contract and see it fail. And so when we run that, and if we look here, so missing access token, right? So that's this one here. So we kind of know that we've hit there as well, because if we go back up, right? If we go back up to our code, all right, this is why we specified, keep going right here. All right. So by specifying some of these, the question marks here, you could do it at other places, but so this is, and with the tracing enabled, that's why we kind of know that we hit, this was exactly where we hit where it was invalid. It shows us, gives it an immediate result, and it's always predictable. So that's why it's important to kind of put some flags in here to make sure you're not failing on something else that you didn't realize. So if you just have, oh, it's a failed, oh, good, that's successful, that's sometimes not enough. Sometimes you need to actually see where in the smart contract it actually failed to make sure your assumptions are correct. So that's exactly what happened here if I actually go back here, right? So in this case, we had, no traces here. This one didn't actually, I didn't actually have the traces here, but anyway, you can specify, oh, actually, so what's that with traces, right? Here I am. No valid PBL token found, right? Exactly. Let's look at that. No valid PBL found, right? So there we are, trace, no valid PBL token found. So that's, yeah, so it's nice to have some information. Again, when you compile this for production or for optimization, you can put in different flags. Let's go back to here for that so everyone's clear on that. So Aiken, oh, right. Or actually, sorry, Aiken build. Oh. When you build your script, you can specify the trace. What I use is the tracing level. So by default, traces are disabled. So when you just do Aiken build and try to compile your script, all the traces will be removed. So you won't see any kind of information. So what I do is I generally put in the Aiken build and then put a T for traces, and then I'll put in the verb rows. That's right. So put in that flag there. So you build the script that actually includes all the tracing. So this includes the explicit, the kind of the trace statements you have, as well as these conditional tests. Okay. And then they show up like we saw up here, right? So it's going to show up whether it passed and also with the and it will also show you. So there's this, right? So it's going to show you this. It's going to show you where it failed, the evaluation. So output to sender failed. And it's also going to, in cases, it will specify this case here, no PBL valid found. So this was here. Yeah. So faucet output to sender false. Right there. Cool. Okay. So those are kind of how you can get debugging information and tracing information sent to these your scripts. Okay, so let's go down here and wrong amount, wrong false amount. So these are kind of basically they're all on a similar vein of basically creating scenarios that will fail, not having the access token and invalid access tokens. You can put some wrong things here as well. So let me go down here. So. Again, so an invalid access token, I just created like a bad, invalid policy ID. Same idea here. Scroll down here, other policy. So you just kind of mix it up, right? You can put in specific things that are going to fail and then just watch it fail. And then the wrong sender is another one. So this is where if you go down here, I put in, in the redeemer, it's the wrong, absolutely, I put in like 97, which is an incorrect value. It should be just 0 based on how I set up the wallet here. So you can see there's different areas where you're going to have to fail the transaction. So that's why it's a bit of an art and a science. Sometimes you're going to fail it by, at this level here when you're kind of building your script and calling your transaction. And in some cases, it's going to be actually in the actual, the mock transaction. So long and the short is that there you are. So you basically, you've got a bunch of unit tests, you run it so you know what they're working. So that's kind of the first step of when you're doing testing, right? So now let's look at the second step, because that's great, but it doesn't always catch what you want. So that's where we want to get into the integration test. So let me go back up here. So first thing you'd have to do is get Docker desktop. So there's basically, you can get it for any Windows, Mac, etc. Let me get this thing out. I can't see that, but anyway. Okay, so anyway, you get the Docker desktop, but it works for Mac, Windows, Linux. And so once you have Docker desktops, if you have it there, let me just go in here. Actually, I'm gonna kill these. Let me just stop this, and I'm gonna start fresh just to show what's doing here. And if you guys aren't familiar with Docker, you really should. It is the way of the future for all development. It just allows you to spin up images, development images, etc. Really easy, and it saves you tons of time and compartmentalizes your development. So anyway, so containers really key. So Docker Desktop's really helpful because it just kind of shows you those containers. So what you need to do is once you have the Docker Desktop installed, you're basically going to go get this Yaci dev kit. And so what this thing's going to do is it's going to spin up a local Cardano node and environment. So then you can kind of interact with just locally, your own kind of blockchain, which is great for local testing. So, okay, so let's do that. Boom, we get that. To grab that, I've already got that. So let me just see here. I'll just add another thing here. Okay, so I already have downloaded that, so I'm not going to do it again. It's already here. Yeah, let me get log. So you'll see basically. So I've already checked out this specific version. So it's in my instructions. So in this test directory, I've created the instructions, but basically grab the Yaci dev kit, go into it, and then check out this particular version. Again, things can change, but for now, I just use this version. This is the version that I got working correctly with everything I needed. Obviously, just you can check to see the releases, but that's what I have. Okay, so now that I've got that checked out, to run the Yaci dev kit, pretty easy. So you just basically run this startup script. So let's do that. So I'm going to go into this. So again, I'm in the directory right now. I'll paste it here, and then we'll just start it. Okay, so what it's going to do is basically it's running the containers. So I have these already downloaded, so it was fast for me. But basically, if you go back to your Docker desktop, you'll see the images, right? So it's got basically some images here that it's running. So it's particularly it's the called Yaci CLI and the Yaci viewer. Yaci CLI has got the one that has the Cardano node running, and Yaci viewer has as an indexer and the blockchain explorer. So let's look at that for a sec. So when we ran it, so basically it started out, it provides some URLs, which is fine. We'll go to those in a sec. I'm just going to get things going. So this just kind of starts it. We basically create a node in the Conway era. Let's do that. So I'm going to paste that. Here we are. Again, hold on, I'll get to those URLs in a sec. So let's go through that. And then once that, we basically would do a start. So we would actually start the node. So this basically creates all the configuration for us, has everything ready, and then now we start the network, right? So it's got everything. Again, it is its own network. It has all the configuration, has the Genesis block. So it's going to create a network and start producing blocks. And we'll see that in a sec. So we just got to wait for this to start. Again, it has very convenient endpoints for us. So it has like Ogmios, so we can submit transactions, and we'll see how that hooks into like the mesh library. Okay, so there. So that's basically up and running. So I'm going to you can always do info, basically get these things. And let's just take a look at like the viewer, for example. So basically it comes built in with an Explorer. Let me just grab this copy. Okay. So let me just grab that. Should there. Okay, and let me just move this away. Sometimes I just need to press home on that one. Okay, so again, it has out of the block its own blockchain explorer. So so it's busy, right? You can see so the blocks. It creates blocks every second. So that's great for kind of again rapid development. And the transaction viewer, we'll go into that in a second. Then it shows the blocks. So this is cool. So that's great. So that's really a nice interactive way. Okay, so that's the blockchain explorer. And let's keep moving along. So now what I'm interested in is we've already done our unit tests. So now we want to do our integration tests. So we've gone through all these stages. So let us go and see how we do that. So if I go into this test directory, that's where this unit tests are. And what I've created there is, there's basically some TypeScript files to help call the Yaci dev kit and execute the tests. So I guess I'll just maybe go through it first and then we'll run it and see if it all works. Or maybe I'll start it. Yeah, let's go through that. So okay, so just go through the package. So what do we need to do? So in this case, we're using mesh and I'm also using jest. So you need to have the right dev dependencies. So I've got jest there, and then there's going to be mesh, and we'll see that where that comes into play. So that's fine. Plutus.json. So this is basically this was generated as part of the when we did Aiken build. So this creates the blueprint file, right, and actually has the compiled code. So that's important. So that's all there. And then we've got, let's go through here, TypeScript config. I'm not going to go through all that, but anyway, that just helps specify TypeScript parameters. So it is important we have the right values here, like something like ES 2020. But let's go through here and see what we got here. So our first thing is, so let's look at our the tests. So the jest has a config file. So again, this just specifies where to find the tests. So when we basically run the tests, it can find them. So that just specifies kind of the directories and map stuff. So if we look at our faucet.tests, so as the name implies, this is for the faucet. And so we're going to bring in, maybe I'll do an install so I get rid of those things, but we're using mesh and we're going to use a couple of their imports, like creating mesh transactions and a wallet and a provider. So I've got it also here. You can create a you can actually hook this into. It doesn't have to be hooked into a local. It could actually be hooked into pre-prod as well. And in those cases, you may already have a wallet that you want. So in those cases, you can just uncomment this, put your seed phrase or whatever it is, so you can basically use a wallet. The issue obviously in hooking into like pre-prod, for example, for doing integration tests, which you will do, but is that you'll need to then obviously top up that wallet and all that stuff. So there's some other manual things you'll need to do as a pre-step. The advantage of using this local node is that you don't need to do any of that. So we're going to basically see how we can fund the wallet locally and just have it run. And where that's really useful is when we're automating the tests. Okay. So anyway, so what we do is we basically create a new wallet. We just set it 0 for testnet. And then we basically describe our, this is how you do testing with these, whether it's Jest or VTest or whatever. Similar patterns here where you describe your test. So it's going to be an end-to-end test. And, we set up what are going to be some of our variables that we're going to use, have a withdrawal amount. And then before all the tests, we basically are going to do some top-up. So this is what I was talking about, where with a local node, you can actually just specify and what Mesh has done is they've hooked in and called some of the APIs. And behind the scenes, let me just explain where that goes. So if you look at the Yaci store, the Swagger copy, I'm going to give instance secrets all away. But basically, so this is the API that you can call, right? So Mesh has done a very nice job to make it kind of abstracted. It's just part of the provider. But basically, under the hood, the Yaci dev kit has all these APIs that you can call to basically do stuff, right? So that's great. So that's how you can, do top ups, etc. There's a bunch of things you can do here. So again, very well designed. I like it a lot. I didn't have to actually use any of these because the mesh library I used kind of covered it, so I didn't have to go to that level, but that is there if you need to. So okay, so then before it we topped up the address, so I basically put in like 200 and then ADA and then 5 ADA just for some collateral, and then obviously after all tests, just say it's finished. So the first thing we're going to do in this is actually we're going to mint some access tokens. So unlike the unit test we could kind of manually construct a transaction and build it. Here, this actually has to be a real transaction. We need all of the things that we would need for the script to work. So we've got to kind of, do that. So let's mint an access token. It doesn't have to be the real one that's in production. It can be any token, but the concept, this will validate the logic of the smart contract. So we're going to mint a token. Okay, so we're going to call that the access token, and then we'll mint, and we're going to call those the faucet tokens. So again, we're just going to mint one access. We're going to mint a bunch of faucet tokens. And then we got to lock them, right? So we're going to lock these faucet tokens actually at the script address. And that's fine. And then we're now going to start actually, finally, going to start actually testing the smart contract, right? So we're going to first going to see, can we do a withdrawal? So we'll do a withdrawal, again, passing in all of the information we need, like the withdrawal amount. And we have all these variables. We all know now because we created it, right? We know what the faucet and the access token, when we went and created these tokens, we kind of got all the information, right? So what is the actual policy? What is the hex name going to be? So all that stuff, right? So we had all that because all this has to actually match up now because this is actually going to be a real transaction that goes there. So okay, so that's lock. Then we do the withdrawal. And in this case, I just like to do two withdrawals because, I just wanted to see, make sure the behavior works. If we do two withdrawals, what happens? So I just do one and then I do another one. And then finally, we just check the balances. So we just get the balances from our wallet and then we do a little check to make sure that, in fact, because we've done the two withdrawals, we should have 200 faucet tokens and we should still have the one access token after all those things. So that's kind of how we set up, in this case, the simple test case here. Most of the heavy lifting, so once you've got that, as you can see, we pulled stuff up here from off-chain is where we actually pulled in this mesh transaction new wallet provider. So let's go to here. Let's go to off-chain. And so this is where we're pulling in all of the mesh core libraries that we're using. And so this is the thing that gets, I would say most of your work is going to be here. So we're going to specify where the blueprint is. And it's not a perfect, I'll be honest, it's not perfect, the separation of kind of the test cases to the off-chain, but it's tricky to do. So anyway, it is what it is. This is really, really pretty good. There could be better separation that we, at some point, just to kind of abstract some of this stuff into different files. But right now, I'm just keeping it here for now. So, okay, so what we do in the off-chain code is we create the provider. Again, that's why this thing, I've got it set up that you could easily just, again, a very small switch. You could just put in your block frost key and then you could be off the races and test this on your pre-prod. The only thing you would have to be aware of is that you'd have to uncomment this before all stuff because this wouldn't work for pre-prod. Okay, so anyway, so that's fine. So that's a provider. And again, I like that. Again, it's nice and abstracted. You just specify your endpoints and off you're running. And so then you can create your new wallet. Right, so I have it, either can provide a mnemonic or basically have it generate a new one. So that's great. So it creates all the wallets. So thanks to Mesh for that, because that was nice and convenient. And then so we've got a bit some other functions that we have called, right? So there's the minting piece. Maybe I'm not going to go into that too much because I don't want to go too much time. But there's the minting. So it's all the same ideas. We're basically from the blueprint file, we basically grab we create kind of the CBOR object. And then there's the faucet contract CBOR. So we kind of have a minting policy and we have the faucet validator script. So again, we pull them from the blueprint. Just make sure you're grabbing the right validator one. And then we actually are applying our parameters. So the application of the parameters, a lot of the times, particularly in the course, has been, you basically, as you're part of the Aiken build, you can apply your parameters. But there's obviously many times where you want to do this dynamically at runtime. And so that's exactly what we do here, right? Because the access token and the faucet token policy, we actually didn't know until we actually ran it and minted it. So anyway, we can apply them real time, which is what this does. So then there really is just two main, there's the class, the messTX. So we've got a bunch of stuff here that we'll pass in, but there are two main transactions. So one is a new transaction. So this is a kind of a vanilla transaction. And basically it doesn't use any validator or Pluto script. It just basically creates a standard transaction. So that's kind of the vanilla. You've got, get your change and basically select some UTXO and build it. So that's pretty straightforward if you just want to spend some UTXO that's in a user's wallet. The other one is more elaborate, actually has a, if you're going to spend it for, that actually has a script. So therefore we just need to worry about collateral, right? So when we create the transaction, so we can create a transaction, that's fine. But then we're going to add in this collateral piece here just to figure out what our collateral is so we make sure we have it. Okay, because as we remember, when you spend a transaction, you don't need the collateral to help prevent against DDoS or some other spam attacks against the network. Okay, so those are kind of the two transaction types. There's going to be a few other things that we need, like get script address, right? So we're going to want to pull this from the actual Plutus script itself, right? So we'll grab that. So that's fine. So we got to have the code, which is that script CBOR that we pulled from the blueprint. We got to make sure we have the right language version and the network ID, and that's going to return the address. So then we're going to come up now with the functions that we actually call in the faucet test. So if I go back up here, right? So the first thing we did was mint here. It's right here, right? So this was the first function we did to mint an access token. So this is what we're calling. We're calling this mint. So we pass in the access token and the quantity, or the token name and the quantity. And so we just go through a few things here to basically, and you would have seen this with any of your off-chain codes. So you'll go through that, create your token. I just have some debugging information, create your transaction, add your Plutus script, your minting quality and your output, and then you're done, right? Okay, so that's it. And so that would mint your tokens. And then once we minted them, then we're going to lock them as we recall, right? So we're doing mint, we do two mints, access token, faucet tokens, and then we're going to lock the token, which is next. So that's this one. So again, we pass all our parameters, same idea. We've got all that, come up with this, we need to figure out where the script is. So there's just some, just got to be careful about here, but the code, again, this is applying the parameters real time, do some debugging information, and then we're locking those faucet tokens that we mint at the script. Have to construct our datum. So that's where we specify this. And that's fine. And then we have the withdrawal, right? So the withdrawal, same idea. I have to specify a few things. Anyway, so I specify the datum because that's obviously quite important. So this is where, again, you'll have seen this before. So we're going to create some variables here, get, our inputs, get our change address, get the script, get the address of the script, and then start grabbing the inputs of the script address. Again, this all has to come from the actual network because, the previous previous steps was to actually lock the faucet tokens at the transaction. So let's go ahead and go grab them. And now we're kind of getting ready, right? So then, okay, so let's make sure there's a datum at that UTXO that's locked at that script address. Let's specify the amount. And again, this is the heavy lifting of, I would say, Cardano UTXO transactions is that we have to put everything together. We have to put in what are all our inputs and what are all our outputs. So then we finally get to the stage where we can actually build a transaction. So in this case, we're using Plutus v3, so we specify that. And we specify what our inputs are. So all the script inputs. Make sure, there'll be a datum present. Pass in the redeemer, and then ultimately we'll specify what's on the outside, right? So basically, we'll put in the faucet token names. So this is going to go to the script address. So this will be kind of the remaining amount. We'll attach a datum to that. Output will basically, this is going to go to the user. So we want to obviously make sure what was the amount of withdrawal tokens we did, make sure we have their access token. And then I just add this extra one here, again, this wallet isn't that sophisticated. So anyway, so we basically are just going to create another UTXO in the wallet to make sure there's collateral. So again, it's not necessarily very sophisticated, but it just kind of makes sure there's always some collateral for when we want to run another transaction. And then we add in required signers. So that's the withdrawal, right? So the withdrawal was, basically we did one withdrawal transaction. You can see it right here. This is the withdrawal transaction. And then we call it twice. And then this here, the balance. Okay, so that's it's all set up. So that's great. So let's try it. Let's see if this thing works. Hopefully it works. Okay, so the only thing I'm going to do is I'm going to install. So if we go into our directory, let's go back there. Let's go here. I'm going to go into the test directory. And so let's do npm. Well, actually, I've already got that. Let me see. NVM and NVM. So NVM is what I use for the node version manager. So I've got 22.13 installed. So use that if not already. So I should now be able to just do npm install to basically get all the node modules, right? Because that's what we've got here. Again, there's some stuff here that would be nice to get fixed up. So I will leave that to the maintainers of these repositories, but this won't affect our testing. So this is going to run right now. So again, right, we've got, so there's our package JSON. So basically we need to install these packages here. So that's what we're going to do. Okay, so it's there. Again, for production, you may want to have these addressed. But anyway, for testing, this is totally fine. Okay, so all our modules are created. So that's cool. So now we just run npm test. Let's see. So because I have my basically I have the this is up and running, right? So this is there. So that's the assumption that this thing is running. So let's see if this works. If it works. Test. And sometimes you might need to restart it if it has some connectivity to it. So but generally it should work. So it's going to run. It's going to execute the tests like we talked about. Okay, so now it's minting. That's cool. Minting the access token. There's minting the faucet token. So now it's going to lock the faucet token there. That's cool. Now we're going to try to do a withdrawal. So it did a withdrawal. It's going to do a second withdrawal. And miracles of miracles, it passed. So basically, as we remembered, right, when we came, so checking the balance, that's how we kind of know. Well, all the transactions were fine, right? So that's great. So everything passed, but obviously, so our final test and our best test is to make sure our balances is what we expected them, right? So that's if we look at our here, check the balances, a test here, right? Check wallet balance. So after all said and done, we should have 200 faucet tokens and one access token. And it worked. So you can see how convenient that is. And the reason why that's so convenient is that you're just working locally. There's no dependencies. You can keep iterating and you're having a very high degree of confidence this is going to work when you go to production. So as part of that testing process, once you're good here, and again, you can hook this into automated testing and your pipelines, your kind of your continuous integration testing. And then obviously you can easily switch this over to pre-prod, and you could actually even switch it over to prod, right? You could actually have some production testing as well. So kind of went fast, but I wanted to go through it and not take too much time. But as you can see, it's pretty cool. And again, I thank obviously the Mesh team for creating Mesh because it's pretty cool. I really thank the Yaci Dev team because I think this Yaci Dev viewer is great. And if I just go there, one more question. Let me just show you. Hold on. So, oops, sorry, my apologies, wrong thing. Let's go here. Info. If I just go back to this, again, a really nice feature as well. And particularly as you're learning, like you can go in here, you can look at the transactions, right? You can see what happened. So I'm just looking at the last transaction. So here you are, right? So this is what was happening here, right? We basically had, we were trying to spend the last transaction we did was that second withdrawal, right? So we kind of had the inputs. This was the script address, three little dots. You could see this was the datum, right? So we had 100 faucet tokens. This was the public key of the wallet that's executing this. And the outputs was, again, 100 faucet tokens and the access token back. And then obviously this was some residuals. Or sorry, actually, so that was the inputs. Here's the output, sorry. The output was the 100 faucet tokens. We already had 100 faucet tokens already created. And then obviously then this is the datum of the output that's there. So again, this is great, right? If you're trying to see what's happening, you've got everything you kind of need. This tells you, I think it's pretty good. There's also some other cool things here. If you just look at the contracts, again, it's got here, it's got your actual Pluto script. It shows your redeemer tags, actually shows, the actual execution units that was generated as part of the, when your off-chain transaction was submitted, and you have to put this as part of the redeemer. So you've got your units right here. So it's got a lot of nice things just out of the box, right? And if there was some metadata, it would show it there, but I didn't have any metadata. And then you can also, here's a JSON view of the whole transaction as well. So you can kind of see all of your inputs and outputs, etc. So that's cool. All right. Okay. I think that that's it. I don't think I have anything else to show at this time. Is there any questions?
What a demo. Thank you, Lawrence. For real.
Okay.
I'm sure folks have questions. I have one to start with.
Sure.
Would you recommend that people see this kind of local Yaci testing as a replacement or a complement to the on-chain testing we're doing with Mocktail inside the Aiken repo?
Yeah, it's a compliment, clearly. Yeah, it's definitely a compliment. Because the reason why I say that is it takes a bit more effort to get the off-chain integration testing working. And once you kind of get familiar with the using the mocktail stuff, like it becomes pretty much copy and paste. So you can whip these off pretty fast. I would say it's kind of like your learning curve is just a little bit to get used to this, but once you've got it, you bang it out in no time. And that was my case too. Like when I basically, my most time was spent was on this PBL faucet. But then when I went to like some of these other things here, like let's go to Redeemer, right? And so I've updated these to have them, right? So I think they should have it, right? So this just took, it was, you had some simple, things that you were doing for this example, and I just easily whipped these up, right? So it took really no effort to put this, once I kind of wrapped my head around how these worked, it was really fast to do. So it would be complementary just because of the time, it's easy to do these things, and they can be easily integrated into your automated testing. And the fact that it automatically works with Aiken check, like it's a no-brainer. So include those by default. I would almost say they're mandatory for any development. There is no reason, because it's so easy to do, there's no reason for them not to be there. Obviously, the amount of them can vary. And then the second part would be doing the integration testing, which again is very important and is really great. But I would say you really want to do both. Okay, that's my opinion anyway.
Agree. It's good to hear from you. Henson, what do you think?
Yeah, overall, I think it's very impressive. Though I use most of the toolings here, including Yaci, but this is the first time that I see that in that organized way of doing end-to-end tests. Though on scene test wise, I have a little bit updates or comments, but maybe after this Q&A session, I could have a quick walkthrough on the recommendation on how to use Fokker and mesh libraries. Yeah.
Sure. Yeah, that's great. Exactly. I just use what I just kind of made some assumptions, stuff like that. I'm sure there's some feedback you
Yeah.
have and whatnot. So that's totally cool. That's great. All right. Does anyone else have any other questions on what I've done or any other questions for anyone here, I guess? All righty. Okay, well, let me start my sharing.
So excited to put this in everybody's hands. Asteria team, does this feel relevant to where you are right now? Can you imagine using any parts of this?
Yeah, most definitely. The I mean, so many things. I guess that's what it is. It's just like there's just a ton of stuff. Uh the I really think that the Docker can, like all in one, like not having to be on another network, if I'm understanding it correctly, like you can have a local like whole network going.
Yep.
Then the whole idea of, testing mentality first. Like what are the endpoints? Like what are and then how to the validate, I don't know if exactly the right, but how to test those assumptions and get them into the right uh, format so that you can quickly, assess, especially if you're going to be making changes, right? I guess that's the whole idea, because as these things update, you need to be able to
Yep.
punch a button and you see that it works and not find out about it later on down the line. Um,
Totally. Yeah. That is actually probably the biggest value of having these tests, both the unit and the integration testing, is when there's changes, and particularly when there's other team members making changes. Like, how do you know, right? Like, That generally when you're in your own little world and you're testing it, you have pretty good confidence you can figure it out. But if someone comes in, they have no idea what you've done. And so this is where the testing framework is great because not only does it have confidence that, okay, yeah, things are still working, but also explains very clearly what exactly is happening and the assumptions around how it's supposed to work. So yeah, it's cool.
So,
Totally.
and when you go into production, can you, in the Aiken build process, take out the tests? Or do you, I mean, yeah.
Yes. Yeah, it's the build. So when you do Aiken build, by default, it strips out all of the tracing information and none of the tests, none of the vodka tests would be included. So just be the
So you
pure
don't have to
code.
change your code. The Aiken compiler takes care of that optimization for you.
And the integration test was just a separate folder, right? That was just some off-chain code I created, right? So, but the way that it's designed is that you can run those tests locally, pre-prod, or even against production if you wanted to, right? So it wouldn't matter.
Yep.
There's minor changes that you would need to do, very, very minor, but it
Yep.
would work.
I think ideally, the transaction that Lawrence built to for the Yaci network, it should be also compatible for mainnet because in the off-chain transaction building side is literally identical, except
Right.
you have to change the keys and other configuration environment variables. They should be identical. So I pretty like this approach actually.
Yeah. No, you're totally right. Absolutely. It should be. I was just kind of lazy and just did it for for Yaki Dev, but absolutely, you're right. That the better way would just so it's just a variable and you just easily switch it out.
Man, I'm very glad, and if I'm listening to myself in the future, hello, keep going, you can do it. A little encouragement, but so much super. And I say this in a good way, like a super dense amount of information, and I would love every bit of code everywhere to have a walkthrough like that. And I will tell you, just as I really appreciated the hike through as opposed to the focus down and drilling. Like I was very, very happy that you didn't get stuck too much into like details that you're like, okay, look, I'm brushing over this because there's other things on the end. I feel like we've gone up to the top of the mountain and we didn't just stay down in the foothills. So
Yeah.
that's fantastic.
Thanks, Newman. That's great. Any other questions?
Hinson, is 10 minutes enough for you to share a couple updates that you're thinking about? Well, it's fresh.
Yeah. Yeah, I just take over from here.
Nice.
So as the maintainer of those libraries, I have a little bit of suggestions or updates because I never write formal release note about what's updated usually because it's still very small in size. So maybe I could take this chance to at least to talk to the audience that is actually using the library. So first of all, I think on the little minor stuff is the import statement of the mocktail and cocktail. Since I guess in the version right now it's already cleaned up such that everything mocktail could be just directly imported
Ah, good.
in the mocktail. Yeah. So they don't really have to remember all the subdirectories anymore. So I think this is pretty convenient. It's also easier for um, the code suggestions when you're writing the Aiken code. For example, I try to delete one of these. Oops, not sure. Yeah, I don't have the linting suggestion here. Never mind. I won't waste time setting this up. So there's just a very minor updates on the Aiken part. And then on the mesh part, since the dependency version of the demo, it has been updated quite a lot. We are right now on the latest version of 1.9.0 and beta these numbers. So why this is beta? Because we have switched the default TS Builder serializers from the WebAssembly one into the pure TypeScript one. And you can always just opt in back to the WebAssembly one, which is the CSL dependencies. but this is fully up to the users. But some of the more noticeable changes is the wallet right now is work in progress. Like what does it mean by work in progress is that we need a little bit of annoying syntax for the wallet initialization. Apparently it's just this line. So whenever we have to we initialize the wallet, have to do the init to make sure that the dependency has been updating. But since the rework of everything behind the scenes is quite a bit of engineering work, we does not expect this update to be shipped in the nearest terms. Shipping as if we could just remove this line again in the futures. Probably we could do that. But for some more complex dependency issues, because we try to move away from the WebAssembly, from the dependency entirely from the mesh code base, there are a little bit of very low level we work on that. But this is the wallet updates. And another thing is that on the syntax wise, I have spotted some mistake here, but it doesn't necessarily crash anything. So it is the datum one. Let me see. Yeah, here. So when we try to define a datum, and we see there is a mix of constructor types. So here we got an integer here, but we cannot use a simply string here for the JSON constructor. We have to use the byte string here, because the byte string, it is wrapping in another bytes. So there's a correct type of it. Alternatively, when we use the mesh typing system, we could do something like this. So there's minor mistakes on the typing, but it's super low level, and even me from time to time, I'm making these kind of mistakes for quite a lot, and it takes literally quite a lot of hours to make sure every typing correct. So from here, I have a little spoiler that I will probably cover in the next week's sessions about the blueprint compiler. Is that throughout the last weekend, I have hacked out one Aiken blueprint passes, like there's a code generations directly to the mesh type. So just from here, I also announced it in the Twitter and the mesh Discord, is that from this VS Code extension, we have just one function built in right now, which is the blueprint parsing. So one quick demo of it is, for example, we are using this prudence.json, which is a PBL forset blueprint, right? And we want all the type information here. And we know that in this blueprint is everything specified. So simply installing the extension, and then we do this pass blueprint to TypeScript. Selecting the prudence.json, then all the type we need are directly passed here. So we can make sure that all the params that we are having the correct type, datum is having the correct type. You see this is a byte string, but not a string simply. And then there's some helper methods alias to make sure that you have been using the types correctly. So this is simply just returning the inputs, but it could give you some type information about whether you have built the type correctly. And with this spending validators, so for example, try to do this. Yeah, just try to do some quick demo. Yeah. So from this spending blueprint class, when you try to dot that, you could already get all the information that you need without to rememberize any of the serializer and deserializer functions. So you just get address information like this, and you get cboy like this, and you got any other informations that as you want from here.
Amazing.
So this is pretty cool little I would say the code generators. For me, because this is have a long issues that I've been facing, is that every time I build a set of Cardano smart contract, I have to spend hours just to compile these type. and making
Yeah.
sure that I
Yeah.
didn't get
How much
fatty
time did you
fingers.
just save everybody?
Yeah, that's really
Yeah,
useful.
please do try it out
Not
and let me know if there's any bugs or issues because this is literally a algo problem. This is an implementation of the repository. So if you ever spot any issues, just create one there. I will try to look at it. And in the futures, I will also try to supporting the Rust toolings that we are maintaining and also some snippet to be provided like EC spending validator code snippet setup. And one more future terms of R&D items that we are super interested in is the off-chain generation. So for the new mesh TX that Lawrence had demonstrated, we try to think about a framework to directly generate the mesh off-chain code or risky off-chain code directly from the Fokker unit testing framework. Because the APIs are pretty much, we can map it to the different libraries. But right now, I think this alone could save us quite a lot of time to align in different types. Please do try it out and let me know if there's any bugs because it's just freshly hacked out in the previous weekend for me. Yes, so I think that's all for my sharing, and I create a PR on this code change. But apparently, I didn't test everything end to end, so maybe Lauren can help me to quickly test the code because I didn't have everything set up. Yeah.
Yeah, well, so that's great. I love the import stuff. That's actually a great feature. So thank you, kudos for that. And then yeah, you'll be able to run. Just go to npm, just go to the test directory, and you'll be able to run tests. Right? You make any change. Obviously, you just need to run the Yaci dev kit, but I've got in that. And I'm just curious. Anyone should be able to just boom run those tests right away. But obviously, yeah, PR would be great, and I'll double check. But anyway, thanks. Cool.
Yep. Yeah, I will also try. So that's all that I want to share. So
Adrian had a question.
no question, but appreciate it, Hinson. Thank you. That's really useful.
Yep. So I stop here. It's more spoilers for the next week. This will be also covered next week when we talk about the blueprint, the specifications, and stuff.
Thank you. Just outrageous. Lawrence, Hinson, thanks for leveling it up. Appreciate it. And so that means, we got Hinson in the lecturer seat on the 8th of April. And so if anybody's got anything you want to talk about on the 15th, schedule is open. Otherwise, we'll pick up with Q&A and building stuff on that day. And Hinson, I just want to give a shout out. We're coming up on BuilderFest 2025. I remember at BuilderFest 24, we actually FaceTimed you as you were walking down the street to talk about precisely this blueprint thing. So there was a table of people who have been talking about this, getting this thing done, and that's amazing progress. Thank you.
Yeah, it's pretty interesting. Burned quite a lot of my brain juices throughout the weekend. I have been quite a long while didn't tackle this. Yeah, tackle this kind of algorithm problems. It's literally just an algo. Like have to recursively look through the blueprint.
I've designed like half of it in my head a few times just as an exercise, but I always get stuck. Like I get to that limit, and you just plowed right through it. So it's awesome.
Yeah. So if you are interested, I could point you to the exact algo that I've implemented for the parser, just for fun to take a look.
We'll do that for extra credit next week. That sounds fun.
Yeah.
Cool. Well, we'll put this one up on YouTube. Andrew's not here, but he just implemented an Andamio a way to timestamp to lectures. So we can also grab some key moments from this one, add those to specific lessons in the course. We'll do the same thing next week. Thanks, really inspiring stuff. Lawrence, thanks again. Hope this is not the last lecture you give around here. If you ever got something else to share.
Thanks, James, and thank you guys for all your work you're doing here. I think it's good stuff. You've been kind of persevering. That's great. And Hinson, again, great work on the mesh and the contributions to the Cardano. It's been very impressive. So you got my hats off, salute for you. Okay. Thanks, guys. Cheers.
Thank you.
Thanks, everybody. See you
Cheers.
soon. Cheers.
Bye.